All right, good morning. It has been a while since we've had a new section of our cells and systems unit, but I am super happy that we are here again today. And I mentioned about, I don't know, 2 weeks ago or so, that when we got to the cell membrane, we would spend some time talking about how the cell membrane does its job. And today we're going to begin that journey looking at the two main processes that enable the cell membrane to do its job. And those two processes are called diffusion and osmosis. Diffusion and osmosis. So I want to start by uh, just thinking about something. You guys know that for those of you that have been in my class, you guys know that I have fragrance sensitivities. I've got allergies and things like that. So if there's somebody, we're not going to name names here, but let's say there's somebody, usually a pretty cool kid, and he spreads his axe on himself. He may start with a cloud of axe all around himself. And if I'm over here and maybe I'm sitting at my desk at the beginning, I'm not going to notice, but little by little, what happens is those particles of perfume or cologne, whatever it is, have a tendency to spread out. And what they'll do is they will spread out evenly. And when a molecule, a tiny particle, spreads out evenly, that is called diffusion. We're going to look at why that happens. You've maybe noticed this before as well when you make yourself um, some iced tea or something like that. When you first drop some iced tea in, or maybe we'll say a little bit of food coloring. When you put food coloring and you put a drop or two in, at first, when you first do that, when time is at 0 seconds, let's say, you notice that it all just sort of pools near the top or wherever it is that you dropped it in. But slowly, over time, those molecules of food coloring or maybe iced tea, whatever it is, will start to spread out. And before you know it, the entire color has changed and it's gone from clear to time maybe equals 30 seconds. The entire um, beaker or glass will become a different shade of whatever color food coloring you put in there. Well, that is basically the process of diffusion. Those are a couple places where you've noticed diffusion happening before. I'm going to share my screen with you, and we are going to go to the PowerPoint for today. And we're going to talk a little bit about diffusion, osmosis, and the cell membrane. So many of you did an excellent job with your cell analogies. I mean, the cell is like a town, the cell is like a city, a cell is like a school. Some of my favorite ones from the past that I didn't see this year, I had somebody say the cell is like a, um, a, a spaceship, and the commander of the spaceship is like the, the nucleus. The nuclear reactor core is like the mitochondria, things like that. The shell of the plane is like the cell wall. The force field or the force field around the plane is like the cell wall. The shell of the plane is like the cell membrane. Just fantastic things I've seen. I've seen things like the cell membrane is like a hospital. The cell membrane, here's one of my favorite ones. The cell membrane is like a prison, and the warden is like the nucleus. The brick wall, the barbed wire fence, those are like cell walls, cell membranes, things like that. Very creative. I liked your work, so thanks for doing that. Anyways, on with the show for today. we're talking about diffusion, osmosis, and the cell membrane. So from the work you've already done, you'll recognize this portion here as being the cell membrane. And most of the time in your drawings, you draw it as just a couple of lines, or maybe one line around a cell, kind of like this. But if we were to look at it super close up, we would see that it's not just a line, although it is thin. It actually comes in two layers made up of phospholipids, bilayer it's called. And the thing about the cell membrane, we call it selectively permeable, selectively permeable. Well, what does that mean? Being selectively permeable, or selectively permeable membrane, just means that it selects what's allowed to permeate through the membrane. Okay, so the cell membrane allows certain things to pass through, but it will stop other things from coming through. And that's happening in both directions. So the cell membrane, we call it selectively permeable. And remember, the function of the cell membrane is to separate the outside parts of the cell from the inside organelles in the cytoplasm. Okay, so remember, the analogy that I used was that a cell membrane is kind of like a security guard. And many of you caught on to that in your projects, which was great to see. Now, most of the time, the cell membrane controls what comes in and out based just on the size of the molecule. So if there's larger molecules, let's say like glucose or certain enzymes, those ones probably don't fit through the cell membrane. The cell membrane is kind of breathable, almost like your skin in certain ways, where in the sense that it has pores. So it has these tiny little holes that will allow water to pass through, water molecules, individual water molecules, and they're also large enough to allow certain ions to pass through sometimes, like sodium or potassium, things like that. But larger molecules generally cannot pass through, and that's just a function of the size. So when you did your research, I'm sure you came across some of these pictures, and this is a 3D drawing of what the cell membrane would actually look like. And you can see that it's made up of this two layers, and I'm not sure which side is the inside and which side is the outside of the cell. This looks like it's the outside environment. This looks like it's probably the inside of the cell. And in truth, remember, this is three-dimensional. What really happens is the cell has these proteins or channels embedded in it, and that's what you see here. It also has these kind of lasso structures that are designed to capture certain molecules and draw them in, and help certain molecules to pass through the cell at certain times. And so this is what the cell membrane would actually look like. So there are two main processes that enable materials to pass through the pores in the cell membrane. The first process is called diffusion. The second process is called osmosis. So we're going to introduce both of those today. I'm going to do part two of the video. I'll show you a couple of diagrams and things like that, but it'll become more clear to you. But for today, our learning goal is basically to get these terms down. Now, diffusion is the movement of particles from an area of high concentration to an area of lower concentration through a cell membrane. Okay, so diffusion happens all the time, but for our purposes, since we're talking about cell anatomy, we're talking about how particles pass from an area of high concentration to an area of low concentration through a cell membrane. Okay, that's diffusion. So if you think of the two examples I used earlier today, I used one example of perfume, so or cologne. Now, the area of high concentration is where the cologne was first bursting into the classroom. And the area of low concentration was basically everywhere else. And diffusion will happen because nature tends to cause different materials and particles to balance out. And that's called equilibrium. So diffusion is just a system in nature that wants to happen. Things want to equalize when they're allowed to move through a solution. So if you think back to grade 7 science, you remember that a solute is the thing that you are dissolving into something else. So the solute is the thing being dissolved into a solution, okay? A solution. So if we think of the iced tea example, the solute are the iced tea particles, and the solvent is the liquid water. In the example with the perfume, the solute is the actual axe or cologne particles, that's the solute, and the air is the solvent. The air is a gas, but it can also be a solvent. So diffusion is the movement of particles from an area of high concentration to an area of low concentration, man. Now, the second process is called osmosis. Osmosis is specifically the diffusion of water through a cell membrane. The diffusion of water through a cell membrane. And this can also happen in both directions. Water can leave the cell and water can enter the cell depending on the concentration. Now, water will move from its lowest concentration to high concentration through osmosis. But solutes will move from their high concentration to low concentration through diffusion. So they're kind of opposite there. Now, the main idea is that nature wants to equilibrium. It wants to equalize concentration. So there's a few learning goals for you today. We're going to end this session because if I make it longer than 15 minutes, it won't upload onto YouTube properly. One of our learning goals, of course, is to learn the definitions for diffusion and osmosis. The second one is to be able to apply them to certain situations and certain cells. And the third thing is to compare them and contrast them. So we're going to stop this one here today. And we are going to continue on with this in a minute.